Okay, good morning, everybody. Uh, this is early for Barcelona, late, I think, for other countries, but early for Barcelona. So let's say we start on time, average. I am responsible for introducing two, I think, amazing speakers. So I think it's going to be a very nice session. Yeah, so let's see. I will, let's say, collect my thoughts after I have seen the presentations, because I know that they can surprise me to begin with. So I will hope to moderate a debate at the end after we've seen the two speakers. Let me introduce you anyway to who we have on the panel this morning. So we have the two Marcos and Mark, very cool. So Marcos, I mean, I'm sure you both know them, but I'm just going to give a little bit of an intro. So Marcos Cruz, who will start, is a reader at the Bartlett School of Architecture in London and was the director actually of the school in the last 4 years, not anymore. I don't know if that's a relief or what, but in any case, congratulations for what you did there. And he's running for many years the Unit 20 at the Bartlett. That is a very well-known unit there. He's also the co-founder of the Atelier Marcos and Marian since 2000. And Mark Burry, no introductions needed, I suppose either, but just to be fair, is the Professor of Innovation and the Director of SIAL, the Spatial Information Architecture Laboratory. He's also the founding director of the DRI, the Design Research Institute at the RMIT in Australia. And he is connected to Barcelona, of course, because he's the executive architect and researcher at the Sagrada Familia. So, introductions done. Let's enjoy the talks.
Is this on? Yeah. Thank you, Marta. I have the difficult task of kicking off the session of today and getting people sort of joining the room at 9:30 in the morning, which is not an easy thing for this city where I lived years ago. The topic of my theme is what I call paramateriality. And I have used this term for quite a few years and chose the prefix para very carefully, because I really feel that this notion of materiality is obviously very fundamental in architecture, but there's something in parallel that is happening that we can't consider sort of developing just in a single progression of what materials and matter means in architecture. And that is when we look at the impact of biology and biotechnology on design as a whole, there is something in parallel that is happening, which to some extent is actually beyond our control. So the prefix para really implies not only something that is parallel that is happening, but also something that goes beyond. There is also something about a notion that there's something auxiliary or almost a deviation or an abnormal condition about materiality. And clearly, if one thinks that, you go, maybe can we turn off the lights, because then the images would be, or make them a bit lower. Could we make the lights a bit lower? Yeah, dim the lights. So if we have here, for instance, a graph where you look at different materials that are being analyzed and you look at sort of different levels of porosity, clearly in material sciences, you go from the metals, the glasses, the ceramics, etc., as very hard materials, different types of composite plastics, down, and you come sort of to the foams. And I come back to that later on a bit, but obviously we are very interested in this side of the graph currently. We are interested in materials that create large mass that we can mold easily, that we can use as molds but can also manipulate quite easily, that have a lot of porosity, which is a very interesting phenomenon, that are also very light. So clearly in this graph, the biological matter doesn't play a role. It doesn't exist there. And again, I come back to the notion of the paramateriality, means that there's something that happens in parallel that probably even creates something abnormal, in the sense that when you deal with nature, things don't always go to plan. They can deviate very easily into something that is either spoiled or infected or simply growing according to a life cycle that you haven't predicted. So I see really the notion of paramateriality as something that has, on the one hand, this parallel, but also in terms of materiality, it has to be fabricated. All the paramaterials or paramaterial conditions that we are dealing with are clearly fabricated. They don't exist in nature as they are standing. They have something performative. This derivative condition really has also to do with the fact that the materials or the materiality is hybrid, is intertwined between something that is naturally grown and something that is inert. And then this abnormal defective, which I spoke about, has to do with this unpredictable life cycle that natural conditions have. Now, a quick sort of going back in history and looking at some precedents where partly this is coming from, and it is that there has been for a long time a wish of architects that architecture could ultimately grow. And Willem Katabelos sort of did these sketches sort of 60 or 70 years ago, sort of imagining that you really could pre-program a seed, and from the seed you could grow your chair or your table, ultimately even a whole city. I'm personally not completely convinced that you could sort of control all this in this complete growth system, this total control mechanism from a pre-programmed seed. But the vision that architecture is not something inert, but in fact, and it's not only inhabited, but it has in its own right something that is pre-programmed and is in a growth or growing process, is very challenging and interesting. John Johansson, for instance, who has this, what he calls molecular architecture group in the US, he has been for a long time sort of talking about, again, a pre-programmed house that could grow into ultimately a full building when there is no intervention of the builder on site to make this. And then you get sort of Peter Cook, who every 5 years works on his veg house project, and who is fascinated with this idea that architecture really is a hybrid. I think Peter Cook's case is actually really interesting and relevant, because when he started this in the 1970s, he was sort of seen as simply an utopian speculation which didn't really make a lot of sense. But currently it's probably more contemporary than he would ever imagine, because this hybridity of the mechanical, the electronic, the digital, and the biological coming sort of together is something that really is inherent to the designs that he was proposing here. This is just something that, by the way, I had the opportunity to see when I visited Taiwan actually a year ago, and they in the south of Taiwan, I gave a talk, and they said that they definitely had to take me to the tree house, the Anping tree house. And the Anping tree house is nothing more than basically a set of ruins where there's a banyan tree that multiplied into something like 30 trees, but it's actually still one organism. And the organism is so powerful that it adapts with its roots to the existing ruin. The ruin is decaying and disappearing, and the tree is growing, and then keeps the sort of legacy of the existing geometry behind. This is not at all computational, or maybe it is, but it's the phenomenon itself that nature has this capability is worth not forgetting. What for me is completely clear is that the modernist paradigm of this division between architecture trying to be concentrated in buildings that are then located in grand, beautiful landscapes that are untouched and are in balance is a fiction that doesn't make any sense. We all know that. And clearly there was a division and a separation which was seen as a holistic image, but it was not, because nature really didn't work as it was pictured here by Le Corbusier, neither did architecture do. So clearly we are moving on to many, many conditions that have been designed by and proposed by many architects, and this is one of our cases for a project we did, Marian and I, for Taipei, where the integration of a park and the building, in particular the facade of the building, is really where from the horizontal plane to the vertical plane there's a continuum, and the complexity of the architecture is not so much the form or the program, it's really how to create a scaffold that holds this park to grow vertically. You well know if you Google green architecture, you get thousands of images and projects that have sort of green stuff on it, whatever that is. You sort of get, I just chose this one here, you get pyramids in the Mexican jungle with housing. MVRDV has obviously worked a lot with proposals in this field. And again, back to our Taipei case, the idea that there is not only a set of sort of structure that holds vegetation, but growth is embedded in panels that are prepared. There's sort of biosolar panels, and there's growth inside the building and outside the building, is of a high level of complexity. So clearly the case I want to make is that there is a hybridity between nature and architecture which is growing in importance, which needs us designers to change in a way not only our knowledge, but clearly work in an interdisciplinary manner with people who we have worked far less with, which are microbiologists, medics, surgeons, etc. A case that I just found wonderful because it shows the gesture in modernism, although there was a separation that Le Corbusier and others sort of had in mind, but you go to South America and you always have the subversion of everything that you sort of put in books, and here's a sort of beautiful case where the building is clearly embracing a piece of nature into it. And you get the Niemeyer house in Rio de Janeiro with its rock formations and again vegetation growing in it. And I just show you a set of images, again to contextualize a bit what happened and what sort of people who are in this field constantly look at. This is one of my favorites when, you know, in the English landscape you get sort of old churches that are covered in such manner that really the building is holding an enormous mass of vegetation that becomes in itself an ecosystem. Or the case in Iceland where the vernacular architecture has embraced vegetation since ever. And this is sort of the macro scale of vegetation. So it's not the micro organisms that I will talk about a bit later, but it's on a larger scale something that you can very easily maintain. Then you get a very big trend which happened sort of in the last 10, 15 years, which is buildings being covered with vegetation on a very high cost. That was in Fukuoka, in this case here, the Van Hoven case, which as far as I know is the most extreme covered building. It's actually a modernist building inside, but it's totally covered. It sort of really literally disappears under this grand canopy of growing vegetation, of growing matter. A house in Japan, in Tokyo, and the François Roche case in the courtyard of Paris. But when we look carefully at what happens here, there is still, in a funny way, a division between what's the building, what's the physical mass of the building, and what is growing. The building clearly is only holding something that is growing. I think it becomes really challenging and interesting when there is a much bigger degree of hybridity and merger. This was a case of a student of ours who was looking at slow motion architecture. And apart from doing studies into ceramics and the digital fabrication of ceramics, she was looking at the phenomenon that when you have vegetation growing in the substance of the architecture, that vegetation in nature, due to its life cycle, is changing in form and in changing its morphology, and therefore it creates tensions that require, in a way, an architecture that can adapt. And this comes from a very simple observation she made when she was walking around in Rio de Janeiro and looking at the old town, like an old city with old pavements where you have grand trees and the roots are destroying the pavements. This idea that a building that creates or is a host for vegetation needs to have a geometry that is gradually adjusting through all the joints to the forces that growth implies in a very slow process, I find very interesting. This is another case done in our unit as well, where on a larger urban scale, the notion of a new ecology being brought in through algae growth and these algae towers in Taipei, and a totally new irrigation system in the city with several buildings covered in algae, with algae production, are sort of images that we are becoming familiar with. But clearly in this case there's something challenging, which is that when you look at the tower, it's maybe slightly small, but the whole thing doesn't really go to plan. So the project was much more focusing on what can go wrong and what do you do when the whole thing is not actually growing beautifully as one sort of always imagines. This leads me to a very important aspect, which is that simulation and monetarization of this process is becoming key, and this is where computation starts playing a very important role. And when you go sort of into computational biology, clearly the software that is being used, which has enormous capability to monitor what is happening in current life, is what for designers is becoming really interesting. So you get sort of software that can simulate how growth patterns can happen. You still get the very basic traditional static drawing, you know, the François Roche drawing of where the scaffold for the building would happen, or the Van Hoven one. But you get a lot of software that is analyzing, pre-analyzing in a way what the environmental conditions will be before you even build something. So the data collection that we are getting from that is becoming, from an environmental point of view, extremely relevant. And here you get a sort of big range of possibilities that you can use, so from wind flows and studies that then in a way dictate what morphologies the buildings are having. So clearly an anti-modernist, again, attitude whereby the building doesn't come first, but in fact what comes first is the analysis of the environment through its flows and its conditions, its temperature variations, humidities and wind flows, and then we gradually know what sort of architecture we might be proposing. This is actually by a group of students from the AADRL a few years ago. And I guess when Alisa spoke yesterday, that she probably showed you a lot of these simulation systems in motion. Just another one, you know, again, familiar stuff when we are analyzing how much actually heat loss there is in facades. I just show this because this means that we are having currently the possibility of pre-analyzing and predetermining a lot of what could happen that will affect this parametriality, this materiality that is based on something that is then growing. I also wanted to make a quick reference to the notion of what I call the living skin. The word skin, this metaphor, is the most used metaphor we use in contemporary architecture. Every single building has a skin, and I wrote a book about the inhabitable flesh of architecture, which was all about demystifying what this word skin really means. But here I just want to mention that clearly natural skin has a few fantastic properties. The first one is that there is a level of porosity that the skin has. It has also a capability to deform, to adapt, to be malleable, to be stretchable. in a way that a lot of our materials are not. It has the capability of breathing. It can sweat. It can defend itself as well through its sweating mechanisms and its chemical properties, also through its morphology. And ultimately, it just grows, means it has a life cycle. At some point, it will probably die. And that means that there will be an entropic process that will lead to a new growth process, which is the one that for us in our field of design we tend to have difficulties with, because this last stage where the thing decays is something that is always a big question mark. In biomimicry, which is a field that I find obviously hugely important, but it's not exactly what I'm talking about today. But in biomimicry, natural conditions have been very thoroughly analyzed, and you get cases like the shark skin that has been used as a model to create swimwear and to allow the performativity of materials to be on a much higher level, simply because nature has developed that through millennia. You get the case of Velcro, which was a pure sort of observation of certain species that have this capability of hooking on to our surfaces. Or this, the case of the hydrophobic textiles that again have been just seen by looking at lotus flowers, analyzing them and using that on a molecular scale in fabrics. But biomimicry, in my opinion, is mainly based on smaller scale products. So clearly when it gets to materials, it's very relevant, but it's much more complex when applied to larger scale buildings, simply because we know architecture is not about only a product or two. It is not really a product. It's something much more manifold and complex than that. Yet the materials that are coming from that side of investigation are really interesting to look at due to their performative qualities. And then you get the whole world of biomaterials, which is really the creation, the fabrication of materials that have other properties. And the properties is usually that they can decay very easily, they can be disposed and biodegradable. They also are made out of natural materials. But also the fabrication processes are really making us rethink completely how we have done traditionally a lot of stuff. And you get, for instance, the BioCouture case of Suzanne Lee, who is a fashion designer, who's well known, who has grown the fabric rather than woven it. And by that clearly have made a big statement against the whole chain of the textile industry, which goes from the moment of harvesting the crops of some cotton down to the factory processes and then the selling process. All this is a big question mark once you start growing the fabric in laboratories. You get the biocomposites of corn that are increasingly important as well, since corn is sort of a material that you can bring into almost anything. And when one sort of hears that 60% of Americans are made of corn, out of corn, you sort of get the power of this material and how it's being analyzed. And then in Ecovative, the mycelium growth waste products that they are using to create new insulation materials is really fascinating. This is where you can see on the right-hand side an image where they are producing on a large scale simply these new panels that are very strongly insulating, and they are only created by having fungi with their roots binding the waste material that comes from carpentry. So the wooden waste is then bound by the roots of fungi. A very famous case that obviously you probably have known about is biobricks. Again, another phenomenon of where the idea that the brick, which is probably one of our most fundamental building blocks, is being rethought since it's one of the most polluting materials we have on Earth. And when Ginger Dozier speaks about it and makes a big case that the trillions of bricks that are being produced are one of the biggest contributors to our greenhouse effect in the world, means that we as architects, we use two big contributors to this greenhouse effect, which is concrete and bricks. So the thought that brick can be grown almost like a coral, and Ginger is sitting in America trying to actually create this on a much larger scale in order to mass produce this, still on a high cost currently, but with the potential that this will become one of the materials of the future, makes me think actually that, who knows, maybe the brick will be able to continue growing and merging with the other brick rather than having to need sort of the mortar in between and having the sort of repetitive pattern, modular pattern. It might be something that has much more of a chewing gum quality, means it has the possibility of merging with others. Another key principle in materials is what is called bioconcrete, and Henk Jonkers has been at the TU Delft for many years analyzing this and looking at the possibility that the most used material on Earth, which is concrete apart from water, which is also one of our big enigmas because we don't know once it's cracking how we're going to solve it. He has been looking at the solutions, and you can see on the right-hand side image, on how these extremophiles, which are bacteria inserted into the concrete, can bind and heal the cracks of concrete, which is in itself a phenomenal principle, because it means that there is not only the creation of the material in the first place, but there's really the question of what happens when the material starts becoming entropic and destroyed, and that's where nature comes in and gives a sort of response that could change the properties of the material. And then, actually with somebody who's sitting in the audience, Sandra Manso, based here in Barcelona, they have been working on for a long time on what they call biological concrete. Again, phenomenal stuff. This unfortunately was not done, this building, in this manner. I visited it a few months ago when I was sort of part of a jury of choosing the best buildings built in this city here in the last 10 years, and we went to see this building here next to the airport. And we chose it anyhow, but the concrete panels were not covered in fungi and mosses and other microorganisms. But I later then discovered that there was a project made with this biological concrete, which is a multi-layered system whereby the concrete is prepared to absorb and create or be a host of all these microorganisms that will then, with lichens and others, cover buildings without any need of any maintenance whatsoever. It's purely an issue of having the right porosity, the right level of the pH level, and the right layering in order for this to happen. So this is amazing, I think an amazing sort of step forward. This is a photograph that Sandra took herself of how in a more detailed version really this will be looking at. In a way implying that there's a protective layer, a protective natural layer that can happen that doesn't require the extremely expensive and complicated apparatus that we need on the so-called green walls. Moving forward, you get moss as a material that is being investigated. As moss and the growth of moss can produce small levels of energy. Paolo Bombelli at the University of Cambridge with some other designers were working on this moss table, which is really the possibility that you have, through photosynthesis, the creation of levels of energy that can power a lamp on a table. So by integrating growth matter into the system and absorbing this energy production even on a very small scale, you can sort of transform the principles of not only of design, but clearly the environmental sustainability of what we are designing. Now, quite a few of these examples that I have shown are really in the heart of what Richard Beckett and I created very recently, which is what we call CindyBio. And this is an international network and forum of designers and also scientists who are working in this field. We did organize a symposium just in June, which was our first symposium, where quite a few people who worked on the materials that I just showed you before came together to London, and where we discussed what was sort of really the new stories that from behind the laboratories and the design studios were coming, so that there's really a shared network. We all know that interdisciplinarity is fundamental, and it's extremely difficult to get to the right people in the right laboratories to open their doors and their knowledge in order to progress with this further. So from a whole list of people sitting at Arup in Berlin, to Ginger Dozier in America, Sandra Manso here in Barcelona, etc., Henk Jonkers, all these ones came together, and it was interesting to realize that we all sort of knew about each other, but we really didn't meet before, which was really surprising. It was the first time that a lot of people shook hands and said, I know your work for years, but we never had the opportunity really to share what this means. For me personally, this comes from quite a few years ago when I edited the AD Neoplasmatic Design, and quite a few of the prophecies in a way that were suggested by quite a few people in the articles of the AD were really to do with the fact that the big digital revolution that we are going through is now starting to be merged by another one that comes from other fields and is having a greater and even more bigger impact in the future on architecture, which is the biotech revolution. And once you merge these two together, you really create a new biodigital paradigm of immense power and influence in architecture. So neoplasmatic design was at the time an idea of trying to bring together and then make a sort of summary of what was available. Since then, this was now 5 years ago, things moved on very rapidly, so SyndiBio was clearly a follow-up of that. Tom Folders in San Francisco has been working, for instance, on a project he called Materialized Protonemata, where he worked with some laboratories on the eastern coast, where clearly the bacteria in the air start growing these small microorganisms that gradually sort of evolve into bigger species, into more visible conditions. And he was suggesting this and making this study for a project he was proposing in Tehran in Iran, where the whole building was simply going to absorb all the bacteria from the surrounding and gradually create its own self-mechanism and its self-ecology on the wall. Steve Pike, who also came to the SyndiBio symposium and who was a student of mine, who in fact developed all this under my supervision, we both discussed a lot this project here at the time, which was to create these big monitor vessels, which were far larger than any incubator in a microbiology department and actually can host. But these big panels that were supposed to be facade prototypes had a growth medium that allowed the bacteria again from the air to start having a reflection of what would grow, and in this case lots of fungi occupying the surface gradually, taking over, and then after a few weeks they would have to be replaced. So the idea that our air is not sterile, and I come back again to a typical modernist sort of a fiction, that this wonderful, clean, sterile air is not at all sterile because it's full of bacteria, means that the responsiveness and the potential interaction of our surrounding and the materiality of our surrounding was tested here with these monitor vessels by Steve, where it clearly showed that our presence was creating these things to happen. There is a very slow motion process, as you can imagine. This doesn't happen in an hour or two. It happens throughout weeks and months. So the growth mechanisms are slow, but then they also decay in a rather slow manner. when Steve was working on this, and this goes back to the year 2000, so this is really quite old stuff, but still interesting because when we were there at Cindy Bio, we were discussing of how contemporary still the problems are, is that you go back, and he was working with 12 different people sitting in different parts of London in order to create these monitor vessels, in order even to acquire the technology to monitor, to scan, to create the vessels, the glass-blown vessels that could contain the algae that was growing, etc. So algae was also something that we was working on, and is clearly one of the most important materials in the biodigital paradigm that we are dealing with. And I move on to Ecologic Studio, who are both at the Bartlett and also were part of Cindy Bio, and again for many years have worked in this field. And they did years ago this Ortus project in Milan that moved on into another Ortus project further down, which became a more complex case, and now finally they are sort of integrating really into an architectural construct, into this canopy prototype that they're building for Milan currently, where algae is integrated into ETFE panels. And again, very interesting, the idea that ETFE specialists, microbiologists and designers are sort of creating a triangle in which the possibility of producing biomass within these cushions, these air cushions, means that the architecture is having different roles to play at the same time. Then we personally, as Marcus and Marian, with Richard, built in 2012 the Algazebo. Now I'm sort of making a summary this morning, and I'm cutting it slightly short, but I think once one is dealing with these topics, I'm always interested in also expanding a bit the field and not being too narrow, and looking at other aspects that I find fascinating. And one of them is that a lot of the work that I've shown you is actually completely non-computational. It's actually not digital at all. It's actually being done by people who don't need computational means to produce in the laboratories what they're doing. Where it becomes really fascinating is when computation starts playing a role. In the case of the Algazebo, we had different intentions. There was not only an aim to create a gazebo in a park that could host or hold some algae. The main idea was, in fact, for the Olympics to create a folly in the park where people could sit, which was literally like an old carcass of a tree that would stand there alone and would create a dialogue with nature. The dialogue here is metaphoric, obviously. We called it an inverted foliage. And the inverted foliage of these quite big canopies and cantilevers were ornamented, because Marian and I are interested in ornamentation, in digital ornamentation for quite a while. At the same time, we had another big challenge here, which was that when you have large steel sheets being cantilevered, the weight they have makes them bend, therefore you have to remove the material in order to make them structurally feasible. In order to remove the material, we saw there was an opportunity to create, in fact, a script that would patternize the material and perforate it, and create this sort of dialogue, as you can see, through shadows and a game where the foliage is sort of inverted on our structure. What we didn't know at the time was that in order to create double steel curvature that is digitally produced and then manufactured with accuracy, you need cold bending, and the cold bending had to be done by these German specialists in northern Germany, where they are the sort of world leaders in cold double steel curvature bending of materials. And that allowed us not only to bend the material and create the right joints, but to discuss with them of how to introduce all these perforations into the material. Because for them, who were used to work with Anish Kapoor, who did all these extraordinary, rather complex morphologies, they were used to do the double seal curvature, but there was no hole in it. Once you have the perforation, structurally the surface becomes completely absurd and doesn't work anymore. So the big challenge was to create these patterns and this very irregular system to be able to be built still with the joints and be structurally capable. Bolling and Grumman, with their support, engineering support, allowed us to sort of also to calculate how the forces would distribute and ramificate in such manner, and with their software Caramba, so that really the patterns could be as light as possible and as pervasive as possible in the canopy. We saw at the same time the Algazebo also to be what I call the scaffold, as it always happened. So the tradition of small follies in the park into which nature can grow in order to sort of hold itself from was clearly something we liked as an idea. Currently the structure standing in Grimsdijk Farm, somewhere in the landscape, so hopefully with the years vegetation will take over. But then the biggest challenge was to introduce, on a very small scale, algae into it. Now that meant that we had the manufacturers in Germany working on the double seal curvature. We were sitting in London, the engineers were in Austria, and UCL Algae were working with Richard on the algae. The algae was inserted into growth medium so that it didn't move around in a random manner, so that it wouldn't simply make the green pots sort of like murky, looking like murky water. What we wanted was to have the algae growing within very particular areas of these containers. The algae was, by the way, algae from the surrounding anyway, and after lots of experiments we found out that the way of doing that was to print through the silicon pieces sort of an internal structure that would be carbon impregnated, so that the algae would attach to the carbon, which is what they feed from, and then hold itself around those. And you can see on the right-hand side, bottom hand, where gradually the algae is focused on the areas. And once we installed it then, in this sort of great moment of inserting something that was done in two completely different places and being merged together, but again the level of accuracy, of computational accuracy on both sides was so precise that things were absolutely fitting. But you see the algae growing around the internal structure that was carbon impregnated and 3D printed at the Bartlett. At night, and this was only a sort of work in progress experiment, some of the bioluminescent algae was starting to create its own light. They died out very quickly because they come from the sea environment. They came from Scotland, and obviously Euston Square Gardens was not really the exact best environment for these algae to grow. Nonetheless, the solar panels were helping them to illuminate it at night. But this clearly is a work in progress, and that what sort of was the main message of Cindy Bio, which was we all share that everything we're doing is work in progress. Nothing has actually reached anything that is conclusive. It's just, by the way, happening. A very, very important case that I would like to mention was that when Jan Worm from Arup in Berlin came to Cindy Bio to show the project of the big facade of the Algae House in Hamburg, which is really the first case where Arup with the consultants SSC in Hamburg and Colt, which is a manufacturer of window frames, got together and managed to develop the first algae facade that really exists. I'm getting to an end, so it's... I thought you were sort of... I'm not showing this obviously for a design reason. As you can imagine from our own Algazebo, our design interests are very different from what happened in this building. But the sheer principle that these panels, these louvers, are filled with algae that is growing is extraordinary. The consultants, the Hamburg consultants, were working on the efficiency of algae flow within these containers. They call them the solar leaves. The algae is growing according to the amount of irradiation they get. The company that was doing the window frames was looking at the right principles of scale and size of how they could also move and become really these shutters that have a dynamic system. And then the whole engineering of how the flow of algae that has to be in a certain flux in order to have an efficient growth so that it can be collected after a certain period to create biomass, which is an incredibly difficult process, was done again by the Hamburg consultants in Arup and requires a massive power plant laboratory downstairs in the building. For those who haven't seen, it's a spectacular actually visit when you see this building standing there with this fantastic laboratory downstairs where all this is being monitored as it goes. What I find really amazing is the fact that from an environmental point of view, it starts ticking quite a few boxes on that level, which I would say from all those who have been interested in this, what I call parametriality, we haven't seen the environmental agenda as our most important one. But increasingly that is something that is of interest, and Jan with his experiments here clearly has shown that a carbon or low carbon footprint building is really possible if you integrate such biotechnology knowledge into the fabric of a building and of design. In this case you have, for instance, another phenomenon, which is that when there is no sun, there's hardly any algae growing, which means that the panels are pretty much translucent and light gets through. If there is a lot of sun, the algae multiplies rather quickly and it becomes a filter, which is basically a very important sunshade. So the fact that this on summer days is a rather opaque filter that controls the light but at the same time is producing a lot of biomass is really, I think, quite significant. Another discovery they made here was that algae can get very dirty. And that is an aspect I'm not talking about today here, but is the aesthetics of parametriality, which is a whole chapter. And that is partly also why algae on building facades hasn't kicked off so quickly, not only because the scientists have noticed that it was not so efficient, also because it can look really nasty after a short period of time, because again it doesn't go all to plan. There's a lot of residue that remains. Once you harvest the algae, new comes in, and once it's dirty inside you can't really clean it. So they found a very efficient sort of system whereby small particles and the air bubbles are constantly cleaning and washing the internal side of these panels, which is really phenomenal. And I finish the talk by showing the piece that Martin and I with Guan Li and Richard Beckett did for the Archilamp, which is actually not at all or very little biotechnological, but it has certain features that for me are very important to show in this context here. We saw the algae selenoid as a piece that would be in fact an insulation wall. We thought it as being something that would be placed outside rather than inside, so it was a funny subversion to put it inside the frac building, where in fact it doesn't do what it was supposed to do. It's made out of foam, so it's insulation foam, and by taking the insulation foam from inside the walls to the outer surface, what we were trying to do was to create a three-dimensional condition, what Marian calls the 2.5-dimensional condition, whereby all these crevices and pockets are potential areas where nature can grow into. At the same time, we are interested in foam and have used foam in many other installations, and went from the CNC milling machines to even the hand finishing. Again, it's something that I find particularly interesting, but I'm not going to get into that right now. But really what we were fascinated with is the notion of biofilms. And very much in the line of what Sandra and the and the team here at the Polytechnic University here in Barcelona developing biofilms is a whole new era. Why? Because it really doesn't need any particular mechanical structure to hold vegetation to grow. It grows directly on the surface of the material through its porosity and through its chemical composition. So the microorganisms that develop on the porosity of the material do that as they do in nature on rocks. And this is Trentophilia, for instance, which is a material we are very interested in, which is one of the basic elements of lichen. Lichen is a fungi and an algae at the same time, and the algae that tends to usually create lichens is Trentophilia, which is the one that tends to be hated by in the world of architecture, is seen as a sort of defect or problem. In our case, what we thought was to create a pattern that gradually would sort of be occupied with the Trentophilia that would cover the surface as an almost protective new layer. The patternization of all this, and that's where for me this is again a work in progress, but probably the kickoff of something that will come, is that rather than the mechanical paradigm of grand structures, the microscale of small geometries that are becoming biomimetic means that they are mimicking the geometries of nature, where the transition, I don't have a pointer, but where the transition between what is growing here and what is the algae that was growing here in the middle, where that moment of transition becomes really the important point. So we worked quite a lot on what sort of exact geometry that this would have, what also containers would be there for the small pockets of algae, and inserted the bits of algae in around the nuclei of these cells. We spoke about the different cells. They follow all the same pattern, but like the seashells, it's the same principle applied to every single new piece. But the fact that, as I said, this is gradually having the same language and allowing a perfect intertwining and transition between the naturally grown and the inert is what we felt was really important. Ultimately, we're really interested in this. This is what our serious interest is in, which is into corals and how they have the capability of really adjusting to the context, of being very, very interactive with the context. I show these images because they are sort of our aim. Now they bring with it a level of vulnerability and of fragility that is not to be underestimated. But they also have a level of softness and beauty that is interesting. They have a level of pre-programmed capability to adjust to the different conditions that is really fascinating. And I finish by saying that paramateriality is really this parallel sense of materiality that comes through from the biotech revolution, that in a way is starting to come diagonally into the world of design, where architecture, in my opinion, should be considered much more of an ecology rather than what we call architecture. In fact, I gave a TED talk a few years ago called Architecture's Path Towards Ecology. Means we are ending up having a much more ecological system than what we ever imagined. Means that the complexities that we can see in coral reefs is what we probably ought to look at in order to understand what we need to do in the current physical surrounding we are working with. I finished with this slide. Thanks a lot. I think I got more or less spot on the time, so 5 minutes more. So thanks a lot, and I guess we will continue the conversation later on.
While Mark is setting up, could I announce that he has organized two groups at 11 and 10 and 11 o'clock for 1 hour each. There are 10 places on the group of 10 and another 2 places on the group of 11.
Sí. ¿Y esos son? This is working? Microphone's working? Yeah. Good morning, Mark Burry. Thank you, Maria, and thank you, Martha, for the introduction. How could one turn down an invitation to talk on the subject of, and the title, What's the Matter? Materials and Materialism in the Age of Computation. So I propose to do something quite complicated, which is ranged between two dialectics. One is the tangible materiality and intangible materiality, and the other is between traditional approach to building and innovative construction. And the reason I'm doing this is to tackle the problem with the word materialism. Materialism, I don't know what the intention was from the organisers, because there are three sort of orthodox interpretations of materialism. The one that usually springs to mind is the social construct, which is a tendency to prefer material possessions and physical comfort to spiritual values. That's I think what people normally think of materialism. But an artist might think of the tendency to lay stress on the material aspect of objects, representation. The philosopher, and this is the definition which I think is most troubling in terms of for the architect, is the doctrine that nothing exists except matter and its movements and its modifications. Also the doctrine that consciousness and will are wholly due to the operation of material agencies. And I'm going to try and put across a case through looking at some work of Gaudí and others that would suggest that there is such a thing as materialism which is not founded on the tangible material but in the intangible. So it'll start with some Gaudí. I'll finish with Gaudí, and there'll be some sort of fairly esoteric stuff in the middle. It's dangerous doing this on a Saturday morning, but we'll see how we go. So let's just organise myself a bit better. So interpreting tangible versus tangible materiality, interpreting Gaudí and the colliding forces of traditional and innovative construction. It's quite a loaded title. Gaudí, apparently, because he wrote nothing of his theory of architecture, but apparently saw innovation as being something you do in design, but not in construction. Why would you risk something not working by doing something novel in construction when you know there's a way of doing it from a traditional standpoint. So we look at Gaudi's work as highly innovative in most aspects, except in the choice of materials. He chose materials around a palette of traditional activity. Fortunately, he comes from here in Catalunya, where the ability to use brick and tile for outrageously, unexpectedly impossible structural solutions was there already. So it's a bit tongue-in-cheek to say that he wasn't innovative structurally, because he was actually working within a group of people who were very adept at taking materials to their structural limits. So I'll just start by setting a scene, because computation will be pervading this talk, but it's as much about geometry and mathematics as anything else. And I really want to address the issue that if we're going to use the computer, we have to know exactly what we're dealing with in order to define it in a way that the computer can interpret it. This model is the 1 to 200 scale version of the Sagrada Familia. It is 2 years old. It shows the original facade by Gaudi, the Nativity facade, and behind there's the apse. So that was all that was built in his lifetime, the 43 years that he was the chief architect for a project that he didn't even commence. He, as you're probably aware, took it on from another architect who had resigned through a disagreement over the choice of materials. But what's interesting, I think, is that the activities that I've worked on personally with colleagues, currently coming to a conclusion with the Sala Croix, which I'll show at the end, and the Passion facade on the other side, were done without the opportunities of working with this model. We simply did not have the data. We did not have a version of the model digitally that we could refer to. So all decisions had to be made relying on our visual and imaginative and conceptual abilities that weren't able to be materialized. Eventually, with the scanning technology that's blossomed in the last 5 years, it was possible to scan the existing bits that had never been put into the computer, and so through the extraordinary efforts of Andreas de Mesa, all those bits were put together, and we have a base model. So Gaudi himself a model together based on a geometry, a set of geometries. So 12 years before he died, and this is really fast tracking into work that I don't usually show, but I just want to put it into context. 12 years before he died, he must have realized that this issue of agency and materiality were actually tied up, that the free-form architecture that characterized his work was very successful from all points of view except economically and practically. So the La Pradera apartments, free-form, not finished to his exact specification, led to a very public battle in court where he had to get his fee for the project, which apparently came in way over cost and over time and wasn't exactly what the client wanted, it seemed. Park Güell, only 2 of the 60 houses were built in that elaborate infrastructure. Of course, my personal favourite, the Church of the Colonia, Chapel of the Colonia Güell, abandoned with just a crypt, despite 8 years of working with a analog computer, which was his famous hanging model, and then another 6 years taking measurements straight from that model to site. The model was on site, and a 14-year process leading to just a crypt. So he invented the analog computer. He completely bypassed the orthodoxy of drawing and modeling in any conventional sense by having this string and weight model. I think this helped encourage him to think about agency coming into the mix. Agency would allow him to have a different kind of conversation with the people he worked with, and also it would give him a different perspective of what might happen once he was gone. Because at the age of 62, which is when this moment arrived, where ruled surfaces such as this one, the hyperboloid of revolution, of one sheet popped up was at a time when he was very infirm with a disease called brucellosis, and he didn't know what his prospects were. In fact, he lived for another 12 years until he was 74, died in 1926, and was run over by a tram. So, in fact, none of the illness came to haunt him in the way that he might have thought. But he certainly did not want to go to his grave with the project in an unfinishable state. So he's aware of these surfaces. This was the hyperboloid. This is the book that he studied, Descriptive Geometry, not the actual copy, but it is the textbook that he would have been interested in, I imagine. 1/6 of his course was Descriptive Geometry, and there he would have seen this form illustrated. It may have been a page that he lingered over. Most didn't, because you don't see these forms very often. Sukhov, around about the time, was doing the radio towers in Moscow, but it's generally a form that wasn't understood. But what's even more intriguing about this geometry is that it's parametric. And in an age of parametricism, which I believe is the digital age, I'm one of the opponents of that term, partly because I've been using parametric software since 1990, and we realized that it was a terrible term, parametric design. So we've spent quite a long time and effort trying to redefine it. So parametric design became associative geometry for us, and then Don Bates, Lab Architects, asked us whether we were actually mapping dreams using parametrically. And in the end, to find a term that everybody could understand and get us away from the dreadful parametric design as it's implied with software, we came up with flexible modeling. So we talk about the flexible model. This is a sort of 2D image of a 3D state of a 4D model. Among you, this audience, maybe you can see that there's actually an infinite number of these shapes residing there. If not, I've helpfully made an animation that can show you what's going on, why these are parametric surfaces. There is the two rings and the strings going between them. And then I'm going to stall the top ring and move the bottom ring around. And there are the infinite number of hyperboloids of revolution that sit there. If you go all the way, you end up with the two cones. So the end states are the cylinder and two opposing cones. But from Gaudi's point of view, I imagine, he was enraptured by, if you look at the light play on this, he was enraptured by the possibility that these forms could give you. And not only that, they are very easily described because all they are is a sequence of straight lines in space that intersect. So whether you're cutting stone or making molds, he had a practical device to allow him to build. But what he did with these surfaces is even more intriguing. He had a tangible method, but it's intangibly stated. Because what you're looking at here is the hyperbola, that is the shape here, simply rotated about a pivot on plaster Paris. So the tangible output is actually this, but it's not actually what's wanted. The intangible aspect is this surface, which is not what's made, it's the result of what's made. So quite an interesting flight in terms of its agency. And with these surfaces, he would then cut them up. So these are geometrical surfaces, cut them up and intersect them. And this is a perfect technique to work architecturally if you're inclined to leave the drawing behind and work in 3D. The surfaces are cut until they intersect, and the intersections are themselves compound curves of great beauty if handled right, depending on the parametric values of these. So my objection to the term parametric design is simply that all design is parametric. I can't imagine a design that doesn't have parameters behind it. So that's why I find it sort of an unusual It's an unusual term to describe something that we already do. But the flexibility of the modelling, which I'm showing you, is not there. This takes a long time to do. It's very effective. We get the triple points, which are the intersections of the intersections, but it has to be done manually, and this model would take up to 6 months to do. So to do a version parametrically would be an iteration of 2 a year. It's not an accident that these surfaces are there. It's quite deliberate. You can see on the fragments of surviving model, the Gaudi's own pencil lines showing where he wants things to be sort of happening. And the way of working at this crossover between pre-digital but post-Gaudi was myself working with the then director, Senor Bonet Gari, almost 90. At the point I joined the project in 1979, we knew that there was a system, but the system hadn't been properly applied. The modelling system I've just shown you is very effective, but if you're trying to do versions at 1 every 6 months, it's not the best route. So my role was to try and find a route through drawing. And the breakthrough was when I realised that it wasn't an architectural problem, but it was actually a geographical problem, that these triple points for the intersections of the surfaces were there in the maps, and therefore I was to produce maps. And these drawings, some of them have these sort of computer look to them. But I'm happy to acknowledge that it was 10 years later before I even touched the computer. This was simply a way of working through drawing to try and speed up an understanding of where these intersections would occur in space. Come up with a system of explaining to the model makers where those curves are on the window in this case, and what the curve is in terms of flicking it around and producing a model like this. So this is to say that the model I showed you at the beginning, where I said it's a 1 to 200 model, it was only 2 years ago that we had the data and also the computer power to show the model. I can then say, but on the other hand, Gaudi had a technique which allowed him to model not at 1 to 200 because it's too small a scale, but certainly at a scale of 1 to 10 and 1 to 25, which was a very effective method to do these design explorations, but not effective in terms of the time it took. So looking back to 1989, which is now 25 years ago, with the first go at using architectural software, it turned out to be quite easy to describe these forms in 3D, but very difficult to intersect them. So we ended up using parametric software, and that's how in 1990 I became aware that there were engineers and particularly aeronautical people who had conquered this issue of trying to get complex surfaces to combine. If you look at the digital representation of this, the parametric qualities of the surfaces, this variable, the flexibility is apparent where we take the tangible way to get the intangible. Here's the intangible thing. In Gaudi's mind, there's no fixed point. The fixed point is simply what ends up as the physical manifestation. I personally think that this is more powerful, particularly when we start seeing it played in in 4D. This is just, there are 9 variables, parametric variables for each of these surfaces, and all that's happening in this one is that this surface here is tipped very slowly and very slightly on that axis here. If you look at 2 variables changing, just one variable on this surface here and one variable on this surface, you can see again this intangible quality. If you just keep your eyes on that line, which is a 3D curve, sometimes it has fascination. This isn't one of those moments, but as it comes round, you can see with the right parameters, there are times when that becomes an extraordinarily rich line. So the ability of Gaudi was to make sure that each time he spent 6 months making a model, he didn't end up with a whole lot of straight lines and sort of 2D curves, that he could find the combination of parameters that would give And the proof of this is if you look at the scanned model, which is the grey one and the orange one on the top. And as I say, there's 9 variables for each of these surfaces, and this is just altering one per surface. And Gaudí must have been able to do all this in his head around all 9 variables. If we look at the this put into action, so might be a way of turning the sound off, but so this is Catalan vaulting for those of you who are not from here. The straight lines that you saw for the description of the surfaces become the straight lines that aid the construction. And every time you get wowed by robots and all the rest of it, just think back to this practice, a tradition that goes back centuries being applied by an architect who died in 1926. There's a way of turning this down, I don't know the means. If we look at this, this is the one A3 drawing that we produced when we started using the computer to make a series of hyperbolic paraboloids that intersect to form the vaults of one of the roof spaces. And the video I have of that here, you can see that one drawing being called into action as one A3 drawing to produce the final surface. So we've got some tile that's been stuck together with plaster Paris, which takes only 20 minutes to set, so it's relatively quick to build this sort of formwork. And then using that one A3 drawing with the data on it. This is from 1998. So another thing I want to get across in my hour is the rapid shift from computation as a way of describing to computation as a way of making. And but at the same time show that there are perfectly feasible ways of making without the computer things that can only be described by the computer in today's age. And here you can see using these it's like a map of data that points in space and straight lines that connect them. These become pieces of string, as you can see here. And the surface is described at 20 centimeter intervals. So you can see the virtual surface there. And the brick tiles are laid underneath it. This rod, it's a straight edge, is laid in some setting plaster where the strings were. And then a line is drawn in there, and an expert model maker is chiseling back to the line. So where that piece of wood had been has come out, a pencil line is drawn, there's a piece of wood there, and we end up with these ridges in space. And I think I've got an image here of the last. There's the finished object. If you want to know how that's completed, I have this wonderful little sequence here for a different part. So you've got those little straight ridges that you've made, as I've just shown you, then using a straight edge going the other way, simply, that's about as elegant as it comes. Right, so that's tangible, intangible materiality. I want to move now to where it gets a little bit more interesting. So, looking at Gaudí's other work, like Casa Batlló, and the so-called organic aspect, I think it's very important to separate organic as being natural-like to organic as a process. So we can link straight back to Marcus's lecture about the fundamentals of organic. The trouble is that there's a big difference between using algae to actually grow your organic response to somebody who's trapped into a world of stone and masonry. And we know that obviously Gaudi's sensibilities are not necessarily animalistic, but that they are organic at this fundamental nature. He understood the value of nature and its opportunities in composition. We see images like this one where a previously living material such as wood has been converted into an inert material, timber. But even in this doorway, you can see the sense of something inside the wood that's still living, trying to get out. If we look at this picture of the foot of one of Herod's soldiers on the Nativity facade, we can see even on a Saturday morning that there's 6 toes to the soldier. And the story is apparently when Matamala came into Gaudi's studio, it was on site, and said, "I found a perfect person to be the model for a soldier of Herod. The only trouble is he's got 6 toes. Shall we model him with just 5? And Gaudi said, and it's a very beautiful quote, which I can't give you, but it's something like, no, we need to let the vicissitudes of nature play out in this facade. In other words, it needs to be as honest as the humankind that's being represented. So Herod's 6-toed soldier is there. Now, that may or may not be something about monsterism, but when we look at the little the entrance to this, so I'm just going to make sure I've got these slides in the right order. Yeah. When we look at the entrance of this, the cloister which Gaudi has going around the perimeter of the building, the rosary doorway, which is this space here, it's a very clever move. He has to take the pedestrian walking along across the facade, 45 degrees through a doorway to the cloister. So that's quite a tricky move. And this is the doorway itself, the rosary cloister. It's a lantern on the top and most extraordinarily voluptuous carving. But on either side of the arch, which springs across where the cloister intersects with that 45-degree space, there are these creatures. On the left-hand side, there's this fish, which if you look closely has a sort of human head that's been, using contemporary digital terms, it's had non-uniform scaling. So it's been squashed as a fish might be, turbot or something. And looking closer at it, you can see that the fish is embracing a woman who's praying and imploring the heavens to help her, because the fish is carrying a little bag of gold, and the maiden is being encouraged to enter a life of prostitution. This is 1896. And on the other side, there's another little vignette being played, which is the salamander, sort of an amphibious newt creature, again with the non-uniform scaled head. And he, or it, is addressing this young man. There's the extraordinary pulled features of the face, and he's handing the young man a bomb and tempting the youth into a sort of life of anarchy, because that was what was happening in society at the time. Famous events at the Opera House where grenades were being chucked into the audience. So it was interesting when we think about the cyclic nature of history, and part of the cyclic nature of history seems to me is to forget that there were previous cycles. So in the beginning of the terror age with George Bush, sort of terrorism was invented as if there weren't such activities in our societies for a long time. Gaudi actually captured this. So it's quite interesting that this doorway, which is so ornate, has these two very profoundly sociologically dark messages that temptation is rife and the youth of the city need to be protected from temptation. Now there's a connection between this attitude of Gaudi to monstrism, which is unexpected and not written about either. So this can only be derived from the work itself. So one of the first projects I had as an architect of the project was to understand the geometries, and we've just been looking at the flexible modelling and the parametric modelling or whatever for this. And I've wowed you with the sense that these curves are perfect, that Gaudi, because this model takes 6 months to make, Gaudi couldn't have made very many of them. He just knew what the values of these surfaces needed to be to get them. So when it came to these emblems around the perimeter, there was a discussion on site with my colleagues about were these simple sort of free-form motifs that just embellish, because all the other decoration is a consequence of the straight line geometry. And I thought it was unlikely that Gaudi would have just thrown these off as sort of artistic gestures. There must be more to it. And when I looked at them closely, I realized that there was a sort of a family story captured here. So this form here and this one are the same topology. They've got different topography. If you look at them, they've got these sort of lens-shaped, curled sides to a kind of pillow. And these ones here, identical too. Same topology, different topography. And the topographical difference is simply the gravitational pull of the ellipse. So the ellipse is a circle that's been pulled out. And so the geometry of this ellipse being pulled has meant that these emblems which go around the edge, the A, B, alpha, beta, alpha, are being pulled out of shape. This means that there's actually an algorithm which defines them. You can say there's an algorithm that generates alpha, which when you change the values of the inputs will give you a similar topology, but different topography through this change. So the question then came was, well, are there two algorithms, the alpha algorithm and the beta algorithm, or is there one algorithm that does both? And there is, because the intangible aspect of this materiality, this material story, is that there's an invisible pyramid. And the pyramid is actually the governor of those two forms. So the blue one is the alpha, and the brown one is the beta. And the two states, the end states, the alpha state and the beta state, means that, that's why I mean it's a bit heavy for a Saturday morning, but I hope you're all with this. And if you're not, at least you can see there's something worth understanding, even if you don't quite get it. And I have had people say they don't get it, even though I've gone to a lot of effort to try and make it explicable. Other people find it easy. You might all find it easy. But what's happening here is that the alpha state, on the base of this pyramid, this virtual pyramid, the side is going from in towards the center of the thing out to the edge. And on the B, this point at the bottom where the pillow meets these blue lenses, it's migrating up the edge of the pyramid. And if we look at point C on the pillow on the alpha, it migrates to a point on the base of the pyramid. Now, it's not a problem if you haven't fully got that. I have got an image here which shows that there's the alpha, we're at alpha, beta, alpha, and down on the bottom right there's beta, alpha, beta. And if I show this animation, you can see that there is an algorithm, a single algorithm. The pyramid disappears from view. We have to remember that it's there. Now, goodness knows how Gaudi conceived this. It's very unlikely that he would be sitting here on a Saturday morning saying there's an alpha and a beta, and I've got point A migrating to point A dash. But nevertheless, it's what he did. And this is measured. It's not a loose interpretation from some rather vague material. The model survives in 3D at a scale of 1 to 10. That's quite a big scale. It's been measured accurately, and this is what you get. Now, because it's an algorithm, it means that you can corrupt it by saying, for instance, what if I didn't get the stopping point right? What if I started the pillow form, the alpha, with too much oxygen? What would happen? And this is where the sort of monstrism is implicit. It's definitely intangible. but it can be tangibly expressed through these animations. So what happens is it goes through the beta form, but just keeps on trucking, because that's the beauty of algorithms. They're not necessarily cooperative unless you actually physically computationally put a number in which says stop when you get to this number. In terms of the materiality aspect of it, it doesn't have to be, because we're now in an intangible world of material, even though Gaudi set this entirely up. I'm not sure if we ever thought what would happen if you made this way out in terms of alpha and beta, but conceived of it as glass. There you can see it sort of settling through the morphing from one to the other. This is all work that was done in 1995, to give you a sense of history. So for a long time, and I'll make this clear in a minute, for a long time this all seemed a bit so what-ish. Here's working with a musician, Errol Taut. And literally, this is what's going on. So it's cold, hard stone, but actually full of life. But the life has to be extrapolated through one's engagement with the numbers behind it. It's not possible to get stone to do this other than through a very sophisticated use of language. So to take this into the world of students, what might they do with this? I conceived a project called Our World. Again, this is in the 1990s, at a time when I had to teach scripting. And there was this notion that you could use scripting for productivity. People could go into offices and be very productive, which is what's happening now, and that's very good. But countercurrent then were the very few people that were actually looking at scripting as a creative tool. So influenced by what I've just described on the understanding these series of morphs that Gaudi was up to, I set the students a task of morphing a sphere into a cube. So quite simple. You could say to a student, for instance, I want you to sketch what you might imagine would be the case of the sphere morphing to a cube in the mid-state. And of course, they would draw something like this, not that difficult. And the difficulty, though, was describing a surface that would be a sphere and a surface that would be a cube that you could computationally adapt. And the presumption was that you needed 24 surfaces joined together as the minimum to make a sphere or a cube work. Trouble is, depending on which surfacing algorithm you used, you got different results. This is the only one that actually works for all the things I'm about to show you, so it means you get a sphere that looks slightly like a nut. This is what we would like to have had, but then you couldn't actually get it to work on some of the contortions which I'm going to show you. Now, I called the project Our World because I wanted the students to be able to work individually with their morphing. So student A would morph the sphere to a cube, student B would morph a sphere to a cylinder. But we'd come together and then be able to combine those scripts into a program. And the program would give us our world of morphs that would be anywhere between a cube that's described by these 7 prime Philebin forms, or 6 Philebin forms, plus the hyperboloidal revolution, just to keep the Gaudi thing alive. So there we can see the morph from the same system, the sphere going to the cylinder. There you can see the cylinder all nicely done. Now, here's the first step. That's the one-dimensional array. when you've combined, you've got student A doing the cube and student B with the sphere, you combine the algorithms and you can produce a 2D array of forms. That's straightforward. If you said to a smart student, what do you think the hybrid shape would be between a sphere that's gone halfway to a cube and halfway towards a cone, they'd probably draw something like that. If you say, well, what if you went the whole way, they may or may not be able to draw that, just from sketching. At least that's my students. If you ask, well, what happens if you go sphere, cube, cylinder, and compare that with going sphere, cylinder, cube, you get the same results. So this is proof that it's computation. It's not a kind of random thing. This is design in the sense that an artifact is being generated intentionally through the use of numbers through the computer. It starts getting trickier and conceptually when you say, okay, student 3, the one who's been making the sphere into a pyramid, combine the softwares and you get our world, that's 1/8 of it. Because remember, it's just the quadrant there, which is 1/8 of the cube. So we're looking at if you go all the ways, then you're going to get a much bigger set. And so that's our world. 1/4, you can see the sphere, the cube, cylinder, and the pyramid at the top. There you can see it going in all directions, and that's what you get. Now, the plan here was to contrive a situation with a relatively few number of iterations. Could we generate a unique object for everybody who's alive today and everybody who's ever lived? And the answer is yes, and you can also give them an individual color. So using this, you guarantee with the simplest algorithm possible, it's only a few pages long, you get not a random event, there's no random number on this, it's just simply highly controlled creation of an individual object per person in the world. The set can also do that problem with I showed you with the Gaudi, where you go beyond the stopping points. Here you can see the stopping point of a cone and a cube, and what happens if you go beyond that. But you don't need to do that for this. In fact, if you just have 21 iterations going between one of these Flavin forms and another, and you go for 9 generations of morphing, you have that required number of objects. So then we started looking at this in terms of narrative. And the narrative was the curator's nightmare, because the curator is the person who wants to collect all these objects. He or she wants to store them in a logical way. And with these three dimensions of morphing, you can do that. You can create the shelving system that allows them. The trouble is that if you then take each of your forms and go for a 4th dimensional move, in other words, you take the cube, the sphere, cube, cylinder, pyramid, and say, I want to go for one more, I'm going to put the wedge shape into it, then you start producing millions of very weird-looking objects. Now, all these objects are describable computationally, and they ought to be describable conceptually. You ought to be able to give yourself the problem, if I go 4 generations, 4 dimensions of morphing, what is the consequent shape? Well, I haven't met anybody yet who can do that. So it's one of these conundrum where the human mind is setting up the algorithm, but it's actually the computational power of the digital that we require to actually bring these into life. So in terms of the intangible, here is the curator's collection, beautifully laid out as glass objects. If he's on some particular trip, then they don't have to be glass, they could be chrome, or they could be stone, or they could be some kind of life-like growing thing. It's for Marcus, he'll not tell me what it is. Plastic, more algae, velvet, and fur. So it's all in the mind. But I've got to bring this back to I have to bring this back into the tangible. So the tangible is here. So just to take you through the morphing, here's the basic trick. There's a sphere going into a cone that's going into a cube, that's morphing into a hyperboloid, that's becoming a wedge, that's becoming a cylinder, it goes into the pyramid, and finally back to the sphere, and that can go on forever if you choose to play it. Here's what happens if you overcook it. You start too soon, so you eventually get to where it should have been, which is the pyramid, through the hyperboloid and on. The curator's collection, you can see why he was so fascinated. He had this beautiful collection. This is only 1/8 of course. He's got to have 7 other rooms to have the rest of the collection. So the narrative about this is the pointlessness of collecting if you feel that the role of the collector is to get the entire collection. Because just when you think you've got the entire collection, he then discovers that in fact, this curator, that the objects are very nice, made of black obsidian. And even though they're the same forms, you now see a completely different personality, a different story altogether. Here's the pièce de résistance. So exactly the same forms, made from this black volcanic glass. As it comes round, you'll see the disappointment in his eyes reflected in the edge of the... There he is. And he realises that he made a mistake with the coloured glass. Well, bringing this back to Earth, what we did was borrow heavily from Flann O'Brien's Third Policeman. So we moved from the narrative of the sad curator to the difficulty of being constrained by 3 Cartesian dimensions, when I've just shown you quite clearly it's an artificial construct. If you're morphing and you keep adding dimensions to your sequence, you give yourself a situation where you cannot store the collection in a way where you can make ready reference. Flann O'Brien talks about birth winds, about the winds, depending on where you're born, what day, which way the wind's going, it will determine your colour. He talks about the colour, intensity of your colour depending on your age, because each year you get another skin of the same colour. And so the same algorithms just being used to give a kind of a visual pictorialization of that story. He talks about objects of such rare colour that nobody can describe them. So that, of course, led us to the challenge of making the objects. So every one of those objects I showed you are makeable. And this is an exhibition that's on in Melbourne at the moment, where we've taken a slice diagonally through that, our world, and there you can see the objects at an exhibition that's called The Future is Here, even though we did these in 1998. And there they are, that fit the physical forms. And then Flann O'Brien talks about Sergeant McCruskin, who makes objects that sit in objects. And he gets to a point where he needs a magnifying glass to see them. And again, because of our digital tools, we can make these objects to do that and easily scale them down to be microscopically small. So just to finish up on bringing this into a practical context. So we've gone, I hope, from a tangible, intangible story to a very intangible story of our world, back to a tangible outcome because we're able to print these objects, the unique objects, one for everybody who's ever been alive and one for everybody who's alive today, to the FabPod. So this is a quote from the book by Puccivala on the Colonia Güell Church, that one where just the basement for the hanging model. And we do not know if Gaudi had completed any special study of the acoustics of this church, but he was well aware that its structure, full of columns, pierced arches, broken volumes and corners, was an effective way to avoid resonance. Furthermore, the hyperbolic paraboloid volts disperse sound instead of concentrating it. We also believe on the base of our own experience that such an internal structure avoids, to a great extent, the echoing that could be produced in the absence of extensive enough absorbent surfaces. So it's hearsay, but it's accurately recorded by a collaborator of Gaudi, well, a young collaborator, in the sense that he attended the lectures. And so we wondered about this. We wondered, do these surfaces actually have an effect acoustically? And it turns out, we're not acoustic engineers, but it turns out when you speak to acoustic engineers, the science of sound absorption is very well understood. So in a room like this, some intelligent decisions have been made, and so we can hear each other. But what we can't do very well is understand what happens when sound is reflected. The proof of this is just how many cafes and bars and restaurants you go to where it's just simply too noisy. I mean, obviously in a cafe you want the sound to be bright and cheerful, but you want to be able to listen to the person next to you. And it's just extremely difficult. So did Gaudi get it right? Had he understood something about these surfaces and the way that they would disperse sound, well, we wanted to know this. So we set up an experiment at the Smart Geometry 2011 in Copenhagen. We're taking the knowledge we had of Gaudi and the way he made his models. You could scale up because on the Sagrada Familia, for making the molds before we started using robots, we had, this photograph was only 15 years old. This would have been routine. If you went to the building when it was still being built, the interior was completed in 2010, you would have seen people doing this kind of thing. It's in a way lost some of its magic in terms of production, even though I would argue that it's gained a lot more magic by being a profound space in its own right. So we set about making these shapes, and in parallel we had the participants of the workshop trying to model computationally what sound might do when it hits these surfaces. And we had Brady Peters, who was at CETA in Copenhagen, was one of our collaborators. He used to be at Foster's with sound, so he's as cluey as they come in terms of sound. He has this room where no two walls are parallel, and it emits a sound, and the response from a 10 centimeter disc is measured. So we asked the students using their software to create a variety of surfaces using hyperboloids of revolution, just as Gaudi had used in the ceilings and the walls of the Sagrada Familia. And each student, or participant rather, made an object. They tested it virtually because we wanted to compare the virtual response to the one that would really happen in that funny living room with the walls that aren't parallel. So they are computationally, there's Rhino and Grasshopper being used to try and understand what is happening to sound in terms of dispersal. Then the surfaces were put into this machine where we could work out the amplitude and the wavelength of the sounds as they were. So you had the difference between a sort of motorbike and a plane being played in that space and producing curves. So that curve there is the response at different frequencies for a particular surface. And when you put them together, we get this. And this is very important. I haven't a clue what it says scientifically, but I do know what it means practically. It means that different arrangements of those surfaces have different responses, because each curve is for a different surface. It means that there is some value to actually understanding what is the perfect combination of those surfaces to get that curve to even out, so that we actually deal with the quality of the sound. In reverberation, we cannot reduce the length of the reverberation. What we can change is the quality of it. And that's the big ask for designers of the future. We tested this at the Smart Geometry by building a token curve wall, and we built another one made from sections of hyperboloidless filaires at, those who know them, at CETA. This is all done in 4 days, by the way. Found a way to make these forms, produced these objects, and then assembled them with Phil's young collaborator. And up it went. And we were able to just test. When you stood in the centre of this wall, you could hear your voice inside your head because it was just bouncing back from this radius. When you stood in front of this wall, there was no such effect. So we were able to show that there is indeed a powerful shift in the way the sound is distributed. Now, this idea of testing as part of your design is something which has been the major lesson from working on the Sagrada Familia, because this is an apparatus that Gaudi himself built to test the strength of stone. So when he was considering which stones to use for the columns, he had these little cylinders cut, and under that rod, and then this load was applied. It's a question I often ask now, that in practice, how do we get this testing, that's such an important part of design, the tangible aspects of materiality, how do we get that into our repertoire? Very difficult. I have an answer because I'm an academic, and that's we should use universities more. Why don't practices collaborate more with universities to do the testing for them? I make that point a lot, but doesn't necessarily get the answer I want. So our next opportunity came when the university, having produced this fabulous new design hub for us, which is a series of what are called, it's on 9 levels, but we have these spaces that have no possibility for subdivision, and which means that meetings can be very disruptive for other people trying to work, and meetings can be very disrupted. So we were given a sum of $28,000 to see if we could put theory into practice. So I'm just going to finish up by taking you through the production of the Fab Pod. The Fab Pod is conceived as this space that's sitting in the middle of the studio. The idea was that it doesn't touch the ceiling, so we don't have to have special lighting, and we don't have to have special air conditioning, because apparently that's what is the big challenge. All around the world, banks particularly, who have made these open and planned spaces, are now dealing with the problem of how to get some acoustic privacy. And the usual answer is something like an igloo, which has to have its own ventilation and lighting. So our task was to see if we could use what we'd learnt from Gaudi and then ourselves at the Smart Geometry to build something that wouldn't have a door, it wouldn't have a roof, and that would use this geometry. So I had to go through the workflow very quickly. We knew what we had to do, we didn't know how to do it. But what is amazing about all these projects is just how much happens behind the scenes. It never ever gets spotted when you see the outcome. So here's the solution of trying to get the intersection of the hyperboloids, is by treating them as an array of a spherical array, a very brilliant, so each of these lines here is an intersection of 2 spheres. This allows, as you'll see, the production of the hyperboloids. There's, as Daniel Davis and Alex Peña de Leon point out, there's a lot of math to all this. There's the coding, which is from Daniel's work. Here we can see, through a happy accident, we're able to get 2D curves, more or less. In fact, they're not quite. There's a millimetre shift in each one of these, so the wall's leaning at the top. The reason for having these spherical arrays is that means that all these joints here are going to be 2D cuts, even though these are sort of apparently randomly distributed hyperboloids. So we're trying to avoid that. That's just not doable if you're trying to work on a budget of 28,000. We then used a whole lot of measurement to work out the disposition of these, Grasshopper and CATIA for doing the workflow. Here's the cell. There's 185 of these cells. Nick Williams was the mastermind for the digital fabrication and the workflow. And these cells were tested and in a sound lab, which you'll see in a minute, and cut. So absolutely masters of the digital fabrication. The objects could be cut out and made what we hadn't realized is there's a big difference between digital fabrication and digital assembly. So we could get the robots to make the objects, but we couldn't get the robots to assemble the thing. We had three materials. Spun aluminium was one for a bright reflective possibility. We had this sort of dense white plastic. Here's the acoustic chamber where they were tested. And the third surface is grey surface, is made from recycled, it's a product from a Melbourne company. It's a recycled drink bottle made into felt. And then we discovered through John Cherry, who's one of the colleagues working on this, that using a temperature of 90 degrees you could form these into hyperboloids. And there you can see that happening. So the assembly was all done by hand. It took 4 days and a whole tribe of students. And here's the object here. It's incredible the way that everybody has adapted to the opportunities outside. If you go there now, you'll find that it's sort of, people have sort of built their research armature inside the sort of, under the walls of it. And then the other innovation was the lighting. The lights are actually transparent plastic with little nanoparticles of something in them, which when they get LEDs from around the edge, putting light down through the material, like through a fibre optic, it hits these little nanoparticles and turns into a white light. At the same time it does that, it becomes opaque. So when it's inhabited, the lights go on and nobody can see in. There's a few portholes left, so that there's sort of it's not too weird. But basically you can get the privacy by having these lights go on. Obviously from the outside, when the lights come on, you can see, so that's with the lights off. There are just a whole lot of transparent portholes. But when you put the lights on, there's a porthole left, but the rest has become lights. So what's extraordinary about this is that it's, again to use Marcus's phrase, this is very much a work in progress. It's not finished. It's finished as an object. It's been up for 2 years now. It's a fabulous space to work in. It doesn't kill sound completely. If you're outside, you're aware that there's something on the inside. If you're inside, ditto. But you can't listen in or listen out. But it's just raised so many new avenues for research. For instance, we've got a new professor, Xiao Jun, who's an expert in noise cancellation through noise. So just like we have the headphones that can kill noise, he's an expert using loudspeakers and very low frequency sound to kill sound. So he's determined to find a way to get rid of the rest of the sound without having to put a ceiling on it. This was meant to be a very lightweight structure that we would just move around. As you might imagine, it's not been moved once in the 2 years that it's been there. There's more work to do on the lighting, and there's certainly more work to do on these surfaces. I'm going to leave it there. I hope I've answered my sort of sense that the philosophy of materialism, where the doctrine that nothing exists except matter and its movements and modifications, also the doctrine that consciousness and will are wholly due to the operation of material agencies. I hope in the middle of this talk I was able to show that that agency can be intellectual and computational. You can manifest it through animation. I've not shown you a single piece of material, but I hope you have a sense of materialism from what I've shown, and I hope you can see that the link back to Gaudi is at least tangible. Thank you very much.
I just want to say that Marcus Cruz has to leave exactly at 1. So we will have a coffee break as planned, but I would like as much as possible that we limit it to 20 minutes so that we can come back here and have the debate and have him leave on time. Okay? Thank you.
Hey, Bob.
Okay, so are you guys ready to start?
Yes.
Okay, can you pay me attention?
Yes.
Okay, so I'm gonna start the debate so that you can go in 45 minutes. I'll try to keep time. Honestly, I have to say that it would have been interesting to have Alisa in this session, and yet also I am very, I have to say that it's an interesting bracket that you guys open up in terms of the work that you have shown and how we can talk about it. There's been a few issues that puzzled me during the presentations, and maybe you can just help me clarify. And the first one has to do with, let's say, this idea you presented, Marcos, about the architecture as scaffold, the building that is covered by vegetation, as opposed to more, we can say, hybrid idea of the scaffold, more in the sense of a porous, perforated kind of scaffold, a little bit like in bone growth, the 3D printing scaffolds for enhancing bone growth for implants and so on. So let's say that this is the idea of the scaffold that I'm presenting or talking to you about. The architecture being a substructure for nature to grow on it, within it, through it, etc. And you were saying in your presentation that because the tensions of nature growing, nature will create some tensions and architecture needs to adapt to it. And I have to say that that is interesting, because I normally saw that nature adapts to anything that is static and solid, and you've shown exactly the Taiwan or this house with the roots, where this is exactly what happens. So I wonder if you can clarify a little bit this, who's the scaffold of who, and who, let's say, between nature and architecture, and what is adapting to what?
Really interesting point. That's why I guess I use this word scaffold maybe 10 times, if not more, during the talk. I use also the word host very often, because there's clearly something about creating the environment and the structural system that holds something else to develop. Now that is, in a way, only the first step, because ultimately the hybridity that you were talking about doesn't have necessarily the scaffold condition anymore. It actually talks about a merger in a hybridity where one doesn't hold the other. They both become together a single entity. Nonetheless, that's the sort of ideal scenario. I think that's where one is sort of tending towards to. But the main situation we have is that we either have the architecture being the scaffold for vegetation, or let's say, for instance, the tree houses is a sort of a banal case, but it's where vegetation is the scaffold for architecture, where somebody builds a tree house into a tree. It means that there's already something growing, and there you build your piece of architecture into it. Means in a way that there's a balance of what dominates what was there before, and what is the pervasive part, and where's the one that is attached into the system. So you can have a reversed system, but as you well pointed out, I think the future interest in all this is when the scaffold becomes really like what is understood in the medical sciences, when we are talking about a completely different scale, first of all, where the material properties are so sophisticated that the growth systems intertwine with the material inert systems in such way that they become really one new entity. And that's why biomaterials play such an important role, because biomaterials are in a way already a hybrid condition in itself. When you look at the fibrous arrangement of how biomaterials are made of, and how they in many cases even have a decay principle, they follow already a different logic. So that I think is really interesting, because it brings into the play an issue of maintenance, of control. But if we go a step back and we think about how do we predict or design these things, I think where it's going to be really, really interesting is where we're going to use tools that we use for simulating stuff to determine with high levels of accuracy of how we want to fabricate this new materiality, this hybrid materiality. And so rather than what I think is my big critique of green facades, to create sort of design a building, whatever the language is, then attach to it a sort of metal grid or some sort of wall that has earth on it, and then vegetation is growing on it, where in a way each entity still remains and is exactly what it was. I think once you start looking at the inherent geometries, even the algorithms that determine what sort of modes of transformation they exist in nature, apply those to certain materials, fabricate them in a certain way that they can absorb the vegetation to grow in a certain way, they start talking the same language. And that's a bridge that hasn't been really bridged before. It means that we need to come sort of in the same way. And I have to mention, I mean, amongst other people, but for instance, the work of Michael Hansmeier. Because I remember when he came to give a talk at the Bartlett and I saw him the first time, my question to him was whether he was looking at biological cases as sort of the paradigms he was trying to mimic. And he clearly said that he wasn't. He was looking from an inside-out mathematical computational logic into what these subdivisions of geometry. Now, subdivision and differentiation are two different terms. What happens in nature is you have a subdivision of geometry, but you also have a differentiation of cellular pre-programmed DNA. And it's materialized because it turns into embryos and it becomes form. What we are doing is we're having a computational logic of subdivision that is hugely sophisticated. We might be getting into a DNA similar level, but we can't materialize that straight away. That's why he was then talking about the difficulties of designing all that, but once he was then doing his columns, he had to sort of go into laser cutting or some other technique that was in a way not responding to what he was trying to do. So I think this bridging that I'm talking about is, I think we are in a very interesting moment where the logics are becoming very similar, but what we need to create, and will rather sooner than later happen, is that the two logics are going to influence each other, so that what we are creating is a new sense of hybrid materiality between both, where the word scaffold disappears.
I understand.
Right.
Thank you very much for clarifying this. I maybe that I wanted to ask something else, but maybe that I will jump over it because of what you say. It has to do with this idea of simulating growth, and the fact that in a way, when with this idea that things will grow and that you can predict or anticipate or compute how they will grow, or begin to, so that you can design your scaffold according to how it will grow, then funny enough, there is this, I think, this difficult relationship between what is expected and what is unexpected, that automatically also comes from nature doing its job, basically. So I think that, Mark, when you talk about the tangible and the intangible, I think that this is an interesting intersection here, because you you, in the case of the Gaudi, you were showing how, you know, how a section becomes the tangible object by which an intangible surface then emerges out of it. And I was wondering if you could make a kind of a parallel of how one would use this kind of approach in the perspective that something would be growing on the structure, or on or within, or that there would be some kind of biological process going on as well, besides the inert stone that you're talking, that you are working with in the Sagrada Familia.
Oui. I think I can turn it back to Marcus's response and answer obliquely. So, if you're looking at tangible and intangible biomimetics or learning from biology, do you know about the linden tree house? In parts of Germany and Poland, right up until 1900, there were people who lived in these houses made from the linden tree. So they actually pruned the tree and sculpted it into a house. But not a tree house. In the tree, the tree becomes the house. So that would be the tangible end of the spectrum. The intangible can be tested in a number of ways. I ran a studio with a couple of colleagues, which we called Atmosphere and Nutrition. It was a combined studio across architecture and industrial design for a few people from fashion and others. And the proposition was that architects think about what their building will look like on a rainy day, or in a place where it never gets the sun? On the one hand, do we design for attrition on the basis that every building starts getting old the day it's finished? Because when you look at the way that architecture is privileged in the press, it's usually without people, because people clutter up the images, and it's usually on the day that the building's finished. But we don't actually look at buildings, I think, as designers that actually are designed to grow old. There's a mineral called desert rose, which is the one which is like lots of lenses. Yep. So one of the most successful projects that came out of that particular studio was for a library. It was on the side of the beach. And the students came up with this desert rose tile that could actually tessellate. So it just made one tile, but it looked like, you know. And it was covered in a special plaster which they experimented in. And the idea was it would take 50 years before the sea, the wind from the sea and the sand would erode the plaster off the wall to reveal the desert rose. So I don't know if it answers your question, but again, it's nothing to do with computation. It's to do with being more sensible in terms of sensibilities, not cleverness, but about our environment. And I think what I find very engaging about the work that we saw from Marcus is the idea that it's about something that changes through growth. It's not an armature just for colonisation. It is actually the object itself. And I always think back to those students who came up with this idea that the building would only reveal itself after the erosion of the sea sand after 50 years. And I think that these are qualities that we don't think enough about. And I think coming into the world of the biologist, we're having opportunities really to think like that, not think about the pristine, completed, materialistly driven object. Materialistically.
Yeah, thank you. I think you helped me. Maybe you want to comment?
Yeah, no, I just wanted to add something which we implicitly touch. I mean, you actually more explicitly than I, which is an aesthetic angle, in particular in this last phase, which is the phase when something is in a growth process. Once it starts decaying, it becomes problematic aesthetically. And you talked about the monstrous. And there is clearly an angle that I think is really worth discussing more. And there are gradually more and more people around in different sort of parts and universities and in cities talking about the value of the grotesque now for a while, revisiting the notions of the ugly. I mean, Mark Cousins wrote these beautiful 3 articles on the ugly and how important it is in the creative process, and how the notion of imperfection is important to consider in all that what we're doing. So in a way, we have default conditions, but then we have those moments where things don't work well, and we know computationally that they are really interesting to be explored. So I'm sort of jumping between bits, but the bottom line is that I think there is an aesthetic potential, but also shift, whereby the notions of elegance, and that's why I have a serious difficulty in accepting elegance as a parameter for architecture that is computational, because I think the non-elegance is as valid, or more valid even, because it steps into territories of the imperfection, of the monstrous, of the defected, etc., that I think in contemporary terms is hugely relevant. We're not looking for the pure clear and perfect and finalized. We are actually much more interested in general terms in the moment of transformation, of mutation, where the thing doesn't have that clarity. And if on the one hand I see in Gaudi's work that clearly there's an angle that one can't really explain, and you said several times, and I heard other of your lectures where you said, here we were sort of speculating of what he might have thought, but we don't know. I think clearly there's another poetic level, etc., but there is something of a language that we can't really explain, where it becomes quite difficult to take rational values to explain this happened, that happened, therefore we can do this. And if I take it back into the natural growth systems, there is a process of growth in the beginning which you can't explain very well because you still more or less can predict. The older the thing gets, the more unpredictable it becomes. When it gets to the end line of a life cycle, it becomes totally unpredictable because there were so many external vicissitudes, so many environmental factors, that the whole thing might be doing something you have never thought about. And that's where it can derail. But I think that is a moment which we are very, very interested in currently. We're looking into the potentials of what is this other side that we can't really explain, but it has a potential because it's the moment where something new will come up from again. And that's where Mark Cousins and some others, I mean, if you go anthropologically, the anthropologist Murray Douglas speaks about the values of dirt and the construction, the cultural construct of dirt, but how potentially interesting the dirty, imperfect, problematic end bits are for the new to emerge. But they're very difficult to rationalize and to explain. And I think there is an aesthetic, broader picture in all this that has to be sort of brought into the conversation that we contemplate.
I find that a little bit, how can I say, provocative in relation to the work that Mark has been showing with the morphing matrices, but you basically expose almost this kind of ultimate notion of control, of we're going to have all these infinite variations where we still are in control of the parameters that are at play, etc. And I was a little bit also curious about these matrices. We were talking about this figure of the curator who would be disappointed because if that was the collection that he was getting into, then he would immediately realize that there is all that other collection he didn't get. And I was wondering how, in front of this, and in this idea of the calculating the optimal or the ugly and the good and the bad that emerges in the other side. How do you think about this work of the matrices, and in terms of what are the questions that one asks them as an architect? Which set of possibilities, or how do you go about choosing in this immense, infinite sea of variables and possibilities? In a way, what is the criteria then?
The selection criteria for me is intellectual, because I find any argument about aesthetics is a great way to spend a lot of time and a very interesting conversation, but inevitably doesn't get me anywhere at the end. I just understand better about that person's aesthetic. So issues about elegance and grotesque as sort of possible ends of the spectrum, I do find fascinating. And when I think of not my peers, more students, because they're easier to attack on the sense that they're starting out, I have this real issue with the random function. Because it seems to me a lot of interesting, inverted commas, outcomes, if we're talking about computation, are by introducing the random function. And then, all sorts of unexpected things happen. It's very exciting, but it's not what a designer does. And I've had this argument, and I usually lose it, so I'm happy to lose it now, but I think I should say it again, that for me, if you've got to introduce a random function into your design process, you've just given something away. Because a designer, it is a controlling activity. That's what, and I often think about, the whole issue of the difference between an artist and a designer, because it's very difficult to separate them. But I think an artist is entitled to use the random function in hypothetical terms, whereas the designer can't, because the designer is controlling a process of taking an idea into a system or a service or an artifact. And if you put the random function in, you end up having to control the effects of the random function. And I'm aware that there's all sorts of amazing things that are emerging. So the point of the Our World is that by putting a kind of a framework around it, which is you've got to work within the bounds of these perfect Verlieben forms, you still get really weird and wonderful things. And so my final comment is, because it's only last week that we finally produced, objects about this size, and everybody's enraptured by them. But some people are enraptured by, because basically it's just it's a sequence of morphs to the extreme of the thing. And obviously the ones with the sort of sexual kind of bits, that's what they are. I mean, they're kind of really weird things. A lot of people get really turned on by them. But some people just like the one that's where the sphere has been biffed a little bit towards the cube and a little bit towards the cone. They love that one the best. It just sits there, rocks around, it's got a spherical base. Who knows? The point is that I would argue that the aesthetic of the outcome is the individual prerogative. But what we need to be able to do is intellectually describe what we've done and its value. And really whether it turns out to be a grotesque or a refined. But what I don't like is when grotesque work is held up as being worthwhile simply because something strange happened, to produce something that's impossible to imagine, very hard to make, but hey, it's really interesting. I just don't think I can't run with that. But then that's because I'm getting old.
But maybe I add to that something that you again mentioned in your lecture, which I found very, very interesting, which is when you spoke about the inherent life that Gaudi's geometries had. And you had some animations where, the morphing geometries and variations of and permutations of the pyramid geometries within the same meant that it was not at all a static, inert condition. It was, in fact, something that was pulsating. There was a pulse within the geometry that is part of its expression and poetic power, obviously. And we, for instance, did an exercise a few years ago for an exhibition in a Baroque church in London. And we had 7 years of, Marian and I, of work with students on sacred and sublime spaces. And then we designed these plinths, and the question was, what are these plinths going to look like for all these exuberant, very ornamented models? And we use as a challenge the term the Bernini folds. We said, look, Bernini is one of these grandmasters who was able, through his genius capability of manipulating material, to make the material speak like another material. And this extraordinary capability that something that is stone starts speaking like human flesh, and literally when I saw these sculptures, I looked around me and I felt some of the people around me had more stony real flesh than the flesh that Bernini had sculpted. I mean, it was as strong as that. And the fact that these sculptures are so alive because the material is so incredibly controlled. In fact, it's beyond a level of control. That's the genius mastery control. Meant that we said the Bernini folds have to be all digitally manufactured. They're all designed with software that we have around, but hopefully they will have a level of expression that goes beyond what these foam pieces are. They cannot look like or express themselves as foam. So clearly we were not interested in the truthfulness of the material, we were interested in the powers that the material has to speak about something else that you otherwise can't see. I have no idea whether we achieved it, but at least we were trying to create these fabric conditions, so the weight of fabric, the gesture that fabric has when it lies sort of a piece of cloth on the table, it has a way of expressing itself that you know immediately it's fabric. And it took several weeks of all the students working on different software, and you got sort of all the Maya gurus against the sort of the Rhino and the Cinema 4D, etc. And they were all with their sort of technique trying to get it until somebody broke through, and we then fabricated them and milled them, and it was incredibly difficult to make these pieces have that sort of pulse, that level of capability of have a dynamic that is within the material because it speaks another language. And I'm sure that you sort of have these conversations part of your intellectual digestion of the work of Gaudí all the time, because there's a rational explanation of what explains how all this thing is done, but then it's also the expression of what it does really say, or how is it having this implicit dynamic condition that is so powerful that makes it not be a static sort of frozen piece.
And it could be done through light or other things, etc.
Of course.
Anyway, to be fair to the audience, we have 20 minutes left. I would like very much that you participate in the conversation.
Thank you. I need to say that it's so important today. We need to be, okay, Alberto Estevez, Barcelona. It's so important to be conscious about today in Barcelona. Marcos is under it's a word under the symbol of the lion, Marcos. And we are part of a chain of evolution that the origin is in Barcelona. Gaudí, the first that is making not computational parametric architecture with his strings models, etc. And now Sagrada Familia is the first building in the history of architecture that apply really fabrication with this first CNC applied to architecture, etc. Before Gehry. Greg Lynn have forget this, but it's true that it's before. And because Gaudí in Barcelona comes Salvador Dalí, Le Corbusier asks to Salvador Dalí, what is the future of architecture? And Salvador Dalí, that knows architecture of Gaudí, say soft and hairy will be the future. And Salvador Dalí in 1956 make the manifesto in Paraguay introducing genetics for architecture. And in 1958, the Verschiebungsmanifesto of Hunter Wasser, that was impressed by Salvador Dalí, by Gaudí, say this very important sentence also for Marcos, that is, let life go inside of architecture. And he began to develop the idea of coming fungi, etc., alive in architecture in 1958. No? And now, well, we are starting in 2000 the research group and the biodigital architecture master, etc., etc. So I only want to say that we are today in an important day with these two point of views.
Thank you.
That comes
very
together
much.
in Barcelona.
Thank you. Is there anybody who wants to? Thank you, Manuel.
Hi, great presentations, guys. I just wanted to make a comment on the whole monster versus elegant thing. If we define elegant in the old-fashioned terms as the economy of means, right? Sort of like a bubble, a soap bubble that reaches the minimum of surface energy or can create a hyperbolic paraboloid if you constrain it in a particular way. we get a sense of what elegant could be, even in terms of the physics. But of course, the moment you start complicating those spaces with multiple local optima, where there's not a single global optimum that can be, say, that the one that does minimize the use of material or maximizes, it does an economy of means in a maximum way, then you start getting choices, which is basically what your mutation spaces explore. And you might start getting things that don't look like, that spend a little bit more, that don't maximize everything to a global point, right? But also the idea that what is monstrous in one era can become quite beautiful in another. If we just think of Mandelbrot's collection of monsters, remember that before he developed fractal geometry, he was just a collector of Sierpinski's triangles, Koch curves, and so on, which were considered monsters at the end of the 19th century. Nobody knew how to classify them. He basically was doing a freak show by collecting all these curves. Once he found the generative principle behind all those fractals and invented fractal geometry, it's very hard to find somebody today that would look at a fractal and say, that's not beautiful, right? I mean, most fractals look beautiful to us right now, whereas 100 years ago they looked kind of monstrous because they defied the differential calculus, right? They were not differentiable anywhere. Right? And so that was considered to be a violation of some kind of principle of nature. So I wonder if the more we know the spaces of possibilities, say, the more we know that a possibility space does not have to have a global optimum that does the maximum or the best possible use of means, and we begin to get used to spaces with multiple local optima that you need to explore them by foot in a way until you find something interesting. The very complexity that we now are used to because we are dealing with it makes us sensitive to things that we used to consider monstrous just because they were not global optima, and that now we consider much more interesting than the very, very simple shapes that come from global optima.
Can I add to this a little bit? Because I think it's a fantastic contribution, thank you. And I think it refers very much, or at least I would like to think so, to the last project that Mark showed at RMIT, where we have the outside surface being, let's say, less locally optimal than the inside surface being more locally optimal. And there is a funny relationship, I think, with fractals in the sense that he used the same geometry at a smaller scale inside than the geometry outside. And I think it would be interesting to hear you talk about, Mark, whether fractal, respond to Manuel, of course, but also I think that fractals are beginning to show up in a funny way.
I can't give you the response you deserve, because I need at least 24 hours to think about it. But there are fractals and there are fractals. There are the fractals I like are the ones that are useful, like if it's a tree diagram or something. The fractals that I don't, when anybody says the word fractal, I immediately come up with those really cheesy things that came out in the 1960s and 1970s, and they were called art. And I always put my judgmental hat on and say it's because you can't do real art. You're hiding behind this effect that you've been able to produce and nobody knows how you did it, but they think you're very clever having done it, and it's very colourful and it's got. But fractals, where it's the actual thinking of divisions and subdivisions. If you take the body as a fractal, I'm just fascinated by the idea that we talked about earlier on the division of labour of cells, that how your finger knows to stop growing, it's reached the right length. Yet you've all come from one cell and you've gone to the sort of great division thing. But when it's tied to aesthetics again, I just find it a little bit tricky. I think the taste thing is also very tricky. It's maybe about taste as well. I suspect I find a lot of the art, inverted commas, that is fractal based, bad taste, because I'm not sure of the actual commitment of skill and artifice that's gone into it. I think somebody's had a lucky break, except for Mandelbrot, of course, who came up with it. But I probably need to think a bit more to give... I think there are a lot of very good points you've raised there.
The majority of you are absolutely right. They have become T-shirts, right? They have become brands or something very, very mundane, right? There's a software on the internet that is actually free. It's called Isophysis.
Manuel, can you speak
I'm
through
sorry.
the
I'm
microphone?
sorry. I
Thank
thought
you.
I was
Thank you.
holding it in my hand. It's called Isophysis, and what's interesting about it, it begins exclusively with the Sierpinski triangle. Remember, it is just a triangle that you take the middle triangle out, and then you start taking smaller triangles until it becomes a kind of Swiss cheese of triangles. The first time you see it, you go, oh my God, but then second time it's like completely, ridiculous. But the iterative or the recursive process that produces, first take the first triangle out, then take the next 2 triangles, then take the next 4 triangles. When you apply to the process, not to the final image, filters like Photoshop filters, like waves and polar coordinates, but because you're applying them to a generative process rather than to a bitmap, as in Photoshop, what you get is a new look for fractals. I would be interested to, if you downloaded Isophysis and start playing with it, you might get a different sense of how to use fractals exclusively for the process, for the recursive process, and then you can affect them in a whole variety of ways and get all kinds of very bizarre things that people won't recognize as fractals, but that have that elegance built in.
Okay. I think the point you made about explaining the principles as helping us to turn something that was considered in a time monstrous to become actually considered beautiful and very elegant, I think makes a lot of sense. That's definitely one of the mechanisms we find, and you see it in many examples. Once you can explain it, you have it somehow under control. It's a human property somehow. But I would like to add to this another angle, which I think is architecturally very relevant, which is the different condition between the outer skin and what is behind it. And what is potentially problematic in the field that I was talking about is that it's an architecture almost without skin, which means that something that for architecture has been always seriously important is that the outer surface quality, being it more textural or less textural, being it with whatever language and morphology it has, it was always considered, and particularly in the classical terms, as being something that gives us notions of beauty. Once you start having a sense of the interior piercing through or appearing, and there again I refer to the articles of Mark Cousins about the ugly, is when he starts describing that the dangerous moment comes when the viscera starts making its presence on the skin, and that's where it becomes very, very dodgy. Now, what I find incredibly interesting in Gaudi's case is that Gaudi clearly works with the inner viscera and the outer skin all the time. It's an intermingled condition. And the moments you show that were the animated ones, were the inner pulse of something of an inner presence appearing on the outside, which is where people sort of feel an awe about it, and it's at the same fascinating. In the world of growing stuff, it's really odd, because it's like an eczema, which means that there is a skin, but the skin is full of weird stuff, and it's not easy to accept that the skin has not this perfection that we always tended to achieve. And we always have been fascinated with the beauty of the geometry and the morphology that we can read, that we know how it works. And therefore, I think there's a shift here. We will have to accept either an architecture without skin or a skin that is perfectly or profoundly flawed because it has properties that we can't control. And they are in process of mutation all the time, which is something we are, from a human point of view, more reluctant to accept. And if this is something of an architectural characteristic, then that's a bit odd, because it plays with the inner being expressed on the outer.
It's very funny. Stig's still here. But, did a project with CETA called Dermoid. I had a fellowship there for 2 years, and I don't know if you know what Dermoid is, but if anybody's got a phone handy, you just Google Dermoid and look at some images, because it's basically a growth on the skin. And Meta, my opposite number there, said, "What on earth are you calling it Dermoid?" And it was about this whole idea of really understanding that the skin and the structure, the outside and the inside, are really much more complicated than we've allowed it to be, because we've had simple choices of materials. But obviously, our future, at some point, we're going to have at our disposal giant versions of the cellular sort of structures that we have at the moment that work so well, you know, for animals and humans. So Dermoid is a very ugly looking thing, but I argue it's beautifully ugly.
Is there somebody else who wants to contribute? Otherwise, I can go on with the question.
It's interesting to see that when nature becomes imperfect, it's because most of the times external forces, climate, temperature, wind, etc. But these external forces makes the imperfections in nature in a continuous way. So at the end, you have a continuous imperfection.
Actually, regarding this idea of perfection and imperfection, it seems to me that it's a very novel way to consider nature as something which is imperfect or maybe even ugly, to use the word which was used in the discussion, because we get used to control nature and to ask nature to obey the different rules of economics. I mean, basically the rules of Western rationalism and capitalism for the last 300 or 400 years, actually. But if you go back a bit earlier, during the Renaissance, during the early Renaissance, or if you go in a different conceptual frame in non-Western civilization, this idea of ugliness does not exist in a sense, because what we consider ugly is considered perfect by some non-Western civilization, and it was the case also during the Renaissance. I mean, even in the worst event happening, I mean, I don't know, some earthquake or whatever, I mean, people saw the manifestation of the perfection of nature, and not always necessarily something which was supposed to be corrected. And this change in the second part of the Renaissance, I mean, for example, with Francis Bacon, who said that we should become master of the nature, and then nature started to be considered as a slave, actually. So in fact, when we keep using this category of ugliness and elegance in this kind of dualistic opposition, my feeling is that we don't bring something new, even if we praise ugliness, in a sense, because we remain completely embedded into this discourse, and it does not matter if we consider it ugly or not. The very fact that we can use this word of ugliness and in this kind of dualistic opposition is a real sign of highly, let's say, modernistic or modernist understanding of nature. So I don't see a real conceptual innovation in that. I mean, in trying to reconsider ugliness. I don't know. I don't see something which is, in a sense, subversive. Or I see this as something super mainstream in the direct continuity of the last 300 years of modernism.
I just respond. I couldn't agree more. I think the word that's maybe missing is politics. I think these are political constructs, not genuine aesthetic constructs, and especially when it comes to level of taste. And so I've been arguing for at least 10, 20 years that we're in this pluralist stage of our evolution, and I don't know how we can escape from it, but I hope we don't. And I think the only thing that will go wrong is if the politics of taste become resurgent and we're told what is beautiful and what is not on that basis. But I think all the points you make are absolutely touch me. Anyway.
Of course, but
If you want to leave on time,
yeah.
you have to really answer shortly because it's now 1:00.
I just want to add a very basic example. If you consider the way we consider, let's say, animals, if you see an animal in the middle of the street, I mean a cow or something like that, you will say, oh, why this, I mean, why do we have this cow in the middle of the highway? I mean, but if you ask to some people in India, they will just say, okay, what is this highway doing in the middle of the cow? I mean, and I think it's, and I agree with Mark actually, ultimately it's a matter of politics and philosophy. I mean, we need to completely change the rules, and it seems to me that in most Western discourse on matter, we don't change the rules. I mean, I worked on the concept of biocapitalism starting in 2000 because I'm completely convinced that we are entering a state in which bio is becoming the new ideology of Western capitalism, as democracy was probably the ideology of some part of 20th century capitalism as well. So I miss some political concept into most of the discourse we are developing today around that.
Could I unfortunately I will have to leave. I just wanted to make a point that these words, perfection, imperfection, ugly, beauty, etc., they appeared almost out of necessity, not as statements of difference. I think we are clear that we probably, in this audience, we all are very interested in not having them as opposites, either or. We are interested in where they are somewhere merged together. And I wanted to leave with something that is an open question actually to Mark, because it fascinated me through this conversation about the inner and the outer, and the inner dynamic quality that exists in Gaudi's work, which is in quite a lot of the images that you showed, and I saw it in other lectures. There's a sort of juxtaposition of geometries that are morphing, that coexist. And the coexistence of geometric understanding and the physical expression of this coexistence of geometry and morphology is something that really intrigues me. And I go back to the case of Bernini, where I forgot now the name of some of his sort of contemporary artists that are also exhibited in the villa where all his sculptures are. And there is this phenomenal case where you see a cloth lying on the skin of a woman. It's all made just out of the same material. But the fact that the cloth is transparent and allows the dynamic of the flesh underneath to be present is fascinating. Means that there is an intermingled, intertwined, underlying geometry with the above geometry. It means the material is worked on different levels simultaneously. And I wondered whether in the considerations of the physical manifestation that you have in the Sagrada Familia, whether that has been considered and actually built into, rather than only the decision at the end where you say, that's what at the end we had to make. Or whether there is actually an implicit juxtaposition of geometry that is actually there and even manifest manifested through the material.
In Rushing Off to the Plane Speed, Daphne and Apollo, Bernini. It's where Daphne's turning into a tree.
Yeah.
The clue is the stopping point. When Bernini made that sculpture, how did he know which bit to make tree, which bit to leave as Daphne?
Yeah.
I'd say that's the only way I can answer your question. It's the stopping. It's the stopping point. That's the element of finesse of the Sagrada Familia, not the physicality of it.
I'm sorry, I have to interfere before you thank. Just to return to my original presentation that you missed, that was explaining the rationale of the conference.
Yeah.
I would return back to my Greekness and say the coexistence should not be in your language because you are referring to an organic paradigm. I think you should stick more to symbiosis and synergy, referring to mixers and parasites. And I didn't hear this, symbiosis and parasites. I was expecting in your presentation this to be part of your discourse because it's a healthy, not derogatory way of looking at parasitic relationships amongst different, seemingly different things that not coexist but have a symbiotic, synergetic relationship in a cosmic worldview.
Absolutely.
Time to go.
Thank you
Thank you.
very much. Thank you very much, Hugo.
Thank you. Thank you, actually, Maria and Dinos. I just noticed that when I gave my presentation, I forgot to thank you for the invitation to be here, and it's great that you're getting the opportunity to get us all together. So, and thanks, Martin.